Wow, okay, this is, okay, 13. She said 13, professor, do for me again. Okay, super. Do you see whiteboard? Uh-huh, okay, okay, 13. Okay, 13 is, in my opinion, is like a little bit stupid question, no? But it's confusing. Okay, I understand very well your concern. So one graph is given. Suppose I create a new one, not necessarily the same of this. 1, 2, 3, 4, 5. Arbitrary, positive value or negative value. It doesn't matter. Thus I have different value of the y. It's completely irrelevant. The y value is not important. It's important, it's not important. Okay, entonces suppose que we have that situation. It's going down, it's constant, it's going up, it's constant, and it's going up. So the question says determine the interval over the function is decreasing, increasing, and constant. Well, it's obvious que the interval when this, let me start for increasing. So increasing, decreasing, and constant. Increasing is when the function, suppose the mnemonic I explained, is you travel onto the curve, like a roller coaster car, no? Entonces es increasing here when the roller coaster car goes up. The motion is always from left to right in x value. Entonces you analyze what happened with the value in y. See the y value increasing, so es bigger, is increasing. Entonces es obvio que the interval in which that function increases this interval and this interval. This is very, very important. The answer can be expressed using always x value. Why? Because x value is the domain value, and domain is the most important set in the function. So one, convention to express that is increasing the function is from 3 to 4 union 5 to infinity, no? In this case, do not include the endpoint. It's a parenthesis because it's a transition point, no? A transition point is the point in which it's a little bit weird because before 3, the function is constant, and after 3, the function is increasing. So what is the behavior exactly in 3? No, I have no idea. So we do not include it in the increasing 3 point. Similar, the function is decreasing. Let me use in rainbow color, que es nice. And this interval, decreasing. This is constant, this is increasing. This is constant, no, only this interval. Entonces, the decreasing interval is from 0 to 2. Decrease. Well, constant, no, constant we have two intervals. Let me try to use this highlight maybe. I don't know. It's good or not. This is constant, and this is constant. But we have two pieces in which the function is constant, 2 to 3. Using that symbol, no? Or 4 to 5. One detail, sophisticated maybe is, okay, and the transition point, I have no idea. What's the behavior? But what happened exactly here in 0? Well, in 0, I have no history before this. Exactly, Alain. This is the idea. You have no history, but that's mean. So see, I ask you, for example, what is the domain of this function? Domain of this function is from 0 to infinity, no? From 0 to infinity. So how you indicate? You indicate bracket 0, comma infinity. This is my domain. So when you indicate the increasing, decreasing interval, I suppose the increasing, decreasing interval is subset the domain. Therefore, what happened in zero? Oh, in zero belong to the domain. Therefore, the behavior is decreasing, I suppose. Exactly, Alain say this is a bracket. But this is, sophisticated. Any question? No, no, no. Yes, yes, yes. It's clear for you, miss? I understand. Okay, okay, okay. I want to complicate a little bit your life now. Okay, another example of this. Pero confusing. No, no, my pleasure, my pleasure. Let me confuse you. Let me try to confuse you. I don't know. Suppose can the test is given something like that. Bone, bone, XY. The curve is just one parabola like that. Bueno, let me try to do my best. This is like that, and this is like that. I put the arrow here, and put the arrow here. And to confuse you, I give you that point. That point is the point, I don't know, negative 4,0. This point is the point 4,0. And this point is, I don't know, 0,8. Okay? Entonces we determine again, increasing, decreasing, and constant. Okay, this is the information that's given. Totally irrelevant information is given to confuse you. And my question is again, determine the interval over the function is decreasing, increasing, or constant. And express the answer in interval notation. Some people try to help me or no? Or no? Or no? Come on. Nobody. Is from negative 4 to 0, from negative 4 to 0. Align, rename, say, from negative 4 to 0 is increasing. I agree, but partial agree. And what happened, Align, in that part? Is increasing or no? Well, you need to understand. Yes, yes. You need to understand what means this arrow. This arrow, is no direction. This arrow indicates this curve continue forever in that direction. But it's actually no direction because you always travel to analyze this from left to right. Always. You travel in that direction. Entonces es obvio que the interval in which the function is increasing is is from negative infinity to 0. Negative infinity to 0. And 0, okay, entonces when you express it in interval notation, you include 0 or no? Parenthesis or bracket? What do you think? Parenthesis or bracket? Parenthesis. Very well. Remember, this is a transition point. Remember, transition point is the point when the function changes the behavior. This is increasing, now it start decreasing. Now there are different kind of transition point. Specifically, this is a local max because it's the point in which the function stop decreasing, not increasing anymore, and decreasing. What about the decreasing interval? Who help me with the decreasing interval? Come on, come on, come on, help me. From 0 to infinity. From 0 to infinity. Okay, so from 0 again, and this is parenthesis for the same reason, to positive infinity. Now what about constant? We have constant or no? No. Okay, super clear. Any question? No, we are the best. Really, we are the best. Betancourt say no, professor. Okay. Please, another question of the review I want. Can you do number 18? Andreina is a number 18, professor. 18. 18. Okay. 18. Let me see what is 18. Okay, 18 is easy. And this is important because you can see something similar in the test. So one graph is given. If 0 is not constant, that y. Okay. Vance asked me about 0. 0 is no constant. Constant is, okay, look. Constant is one interval. One interval is of point. It's a constant. But si it's only 1 point, stop here and go back, say, go decreasing. This is the transition point. This is the local max or local mean. In this case, local max. A constant is when you have a bunch of points that have the same behavior. This is constant. Clear, mister? Or confusing? Come on, we're discussing in detail everything. Clear. Okay. Andreina. Let's go to Andreina now. Andreina wants I try to do 18 problem. 18 problem is also easy, but it's confusing. I understand very well. Because it's a function that is given graphically. No equation, no, graphically. And you evaluate in different points. Entonces, for example, this is -1, this is 0, this is 1, 2. In this interval, my function look like a parabola, like that. A piece of parabola. Okay, and this point 4. And this point 1. And after 2, it's a constant function, it's 5. Okay. Here is 5. The level of this is 5. Here, in the negative part, is we have 1 point here against -1. But this is the whole, and this is a line. Okay? This is a graph. This information is given. And you need to interpretation this and evaluate. Evaluate, find the value, no? And 4, let's do it one by one. And 4. Well, 4 is located here. 4 is x value, domain value, x value. And 4 here, 3, 4. Now I try to find the y value associated with this 4. So I have no equation, but I have a graph. I move to the graph in the direction that you touch the graph. I saw that down we have no graph. Up, yes, is here. And the y value associated is 5. Okay, F evaluate en -2. Entonces sometimes you need to be aware to extrapolate some problem out of the game. Because the motion of interval is located here. But we have, for example, another point. -2 is here. -2, I move it not up because we have no graph. We move it down, no? And this is extrapolate. Extrapolate using your common sense, no? So in this case, I suppose this is a line and passing through the origin approximately, this is -2. Now, so you put -2.1, I said that because graphically. And graphically, no, there are no accurate answers. It's approximately, because I understand that you have some idea about that, -2. Because this, I suppose that this line passing through the origin is like a 1 equal x, no? So the x and the y is the same. It's a supposition. I assume that. My common sense. Maybe your own common sense is different, but you get similar answer. F evaluate en tu post. 2 is very, very interesting point because 2, we have that situation. We have here close, we have open. It's obvious que it's defined and closed. The answer is 4, no 5. So we have in this graph, we have different situations. We have, for example, you have the most typical is you have open and close. This is undefined and this is defined. Maybe in another example, you have both open. So it's undefined both. Never we have that situation. Because this is a contradiction of the function. Remember, one x value is impossible associated with the 2y value. It's a contradiction. Never you see this situation. You see this or this. The most common situation is the first one. Okay? So 99% is something like that. And 1% is something like that. Okay, let's continue. Well, so you understand. You follow me? Everyone follow me? It's clear or confusing? Evaluate 0. Evaluate -1. Okay, super. Evaluate -1. Evaluate -4. Okay. Very well, guys. -4. Evaluate -5. Evaluating 5, 6, 7, and 8. Wow. It's okay. And 0, Andreina, is here. And this point is the point 0,0. Therefore, the y associated is 0. And -1. Oh, -1 is complicated because -1 is here. Look. So in what direction I go? I go down or I go up? Or I go up because I can see here the point gets close, gets defined. This is undefined. So that's 1. -4. -4 is the same stupid thing, right? -4 is -4 because I assume okay, this line is the line y equals x. And -5 is the same. And +5, 5, 6, 7, 8, 100 is 4. F5, sorry. F5. F5 because it's a constant. Look, constant. This point is the point 4,5. This point is the point 5,5. This point is the point 6,5, and so on, etc. Any question? No? Thank you. Pleasure. Okay, super. One more question do you want I do for you? One more question do you want I do for you? One more question you want I repeat for you? Tell me, what number? No? Could you use in the example with 2 open circles? Okay, we can. Good idea. Good idea. I like that. Let me create one weird function that we use in that situation. For example, this is 0, this is 1, this is -1, this is 2, this is 3, this is 4. It's a -2, it's a -3. Suppose that we have that situation. We have a line here. Open. Suppose that we have a constant here. This point is 1. Now this point is 4. And we have here. Okay, in that direction, infinity. Right, let me try to do this. Like that. In the negative direction, let me don't complicate your life. Look. No, I want to complicate a little bit. Suppose that this is close and this is constant. And this level, remember, was -1. Suppose this information is given. Yeah, you want to complicate your life. Evaluate the function in 0. Help me. Evaluate the function in 0. It's 0. Very well. The y associated because that point is 0.0. Evaluate the function in 1. Undefined. Very well. Very, very well. Undefined. Why? Because we have 2 open. We have no value associated in 1. No. Undefined, undefined. Select 1 is closed, entonces it's the value for the close. If both are open, undefined. And both closes is impossible because this is another function. Very, very well. Suppose the function evaluating 3. Or suppose the function evaluating 4. One, very well. Suppose the function, let me try. Evaluate negative 1.5. Here, negative 1.5. Undefined it because we have no function in this interval. And the function evaluate negative 3. Here, negative 3, I suppose, negative 3. Negative 1, very well. Okay. I am happy, but I want to complicate a little bit. Look, please look at the graph. Tell me what is the domain of this function. Domain, remember, is the x value in which the function is defined. Si it's undefined, no belong to the domain, no? I remember to have some idea how the domain look like. You projecting the curve, any point on the curve, onto the x-axis, no? Entonces, well, I can see here, domain, but over here, stop. I have a gap here. Oh, wait, I'm confusing. Okay, here, the part, the projection is the blue part. That part, the projection is the blue part. And that part, the projection is the blue part. But this line is not continuous because we have a hole here, right? Here, 2 holes. Here, no. Here, no, because we have associated. So this is continuous. Super. And here we have a gap. But in this case, put a bracket because we have the function here, but we have no function here. Do you understand this projection? Oh, no. Okay, now ready. Exactly. From negative infinity, let me copy Banks amazing say que negative infinity, comma, negative 2 bracket, union, paréntesis, negative 1, comma, 1. No include 1. Union 1, comma, 1, comma, 1, comma infinity, no? ¿Es correcto o no? Align and Banks, amazing. Okay, what about range? What about range? Well, range is different because range is the projection onto the y value. I suppose I don't see, doesn't matter if you start for the up or the down. Okay, suppose here we start in 4, but we have no projection in 5, 6, 7. No, we have no. We start here in 4. I have no idea if include or not 4. After I can see. Projection. Green color projection. It's the range projection. Here we have, I don't know, we continue here. And stop, no? We have no curve, no function in that part. Let's see. In 4, we have value. Because it's 0, no? 0, 0, 0, 0, 0, 0, 0. And 4 is, in 3 is 4. Look, belong to the range. So this is a bracket here. Because we have here this closed circle. And then 1, never, because it's open, no? Entonces, something like that. The rest, no problema, because it's a line, it's continuous. But in negative one, we have, for example, -3 and -1, look, the range. And also in -3 and -4, okay, so this is bracket. So what about range? Help me with the setup, the range and interval notation. Come on, negative infinity, positive infinity. 0, 1, 4, -1. Who help me? Nobody? There. What happened, guy? I suppose, okay, negative infinity, no, because negative infinity is in that direction, look. Okay, is, for example, in -2 and -3, we have no function. -1 and 4. -1 and 4, no, because we have a hole in 1. Andreina. Okay, we start, okay, -1 to +1. Pero bracket o paréntesis. I like that answer. Bracket, -1, 1, parentheses, because here we have a hole. Look, open. Union, 1, 4, and 4 bracket. This is the range. Confusing or clear? I know, okay, this is too many details, no? But it's okay. Andreina, how do you feel? A little confusing. Okay, come on. Why? Come on, activate the microphone.
Hello?
I am here.
Okay, I thought 1 would be defined in the range because like f of 4 is 1, so I thought that's why it'd be defined.
All right, let me see. F and 4. Oh, yes. You are right.
Okay, I am?
Okay. No, you are right. I am wrong.
Okay.
Listen to me. Listen to me. This is open, but we have another point here. Que the value is 1. Entonces, es obvio que this is no hole. It's completely, okay, it's from -1 to positive 4. To 4. 1 do not participate in the game. It's totally continuous here. So, and 1, the conclusion is, I believe in 1 we have a hole for this and this. But actually, no, because another value of the domain 4, 5, 6, 7, the value for the y is 1. So, basically, in 1 we have no hole. It's totally continuous. The range is from -1 to 4. You are right, mister. Yeah, this is an example I create here. So I improvise. I don't see before, no? I create here. Maybe I make mistake. Okay, super. Don't say, and I was right. I was or you are right. Present or past. Understand, align. Okay, any other question? Any other question?
Wait, so 2 and 3 are defined, or?
Say again?
So 2 and 3 are defined on that graph?
Now let me see again.
Because I thought it would be from like -1 to 1 and then just 4, because 4 is like a line.
Okay, your question is about the range, no?
The range, yeah.
What about what is your point? Okay, don't understand very well.
Because the way I see it, you could correct me if I'm wrong, it's from -1 to 1, and then it's just 4, because there's nothing between 2 and 3 on the range.
Absolutely. We have no here. We have a gap. Absolutely.
Okay.
Absolutely. Wow, you are amazing student. Okay, look, it's bracket -1, comma 4, comma 4, no, comma 1, comma 1. Okay, comma 1. Include 1 or no? Absolutely.
Yes.
Include union. So we have no value of the y in between 1 and 4. 1 and 4, yes. It says here we have a gap. So the only value is 4. But 4 is no interval, it's a point, no? And
Yeah,
4, you indicate like that. 4.
Okay.
Very, very good. Very, very good. Thank you so much for your participation.
No problem.
Any other question? Do you understand the last part, guys? I realize okay, we have a gap here. A gap here. We have a gap. Okay. Lustin say yes. Okay. Any other question? Yes, please. Lauren, Guerra. Do you have a question or no? Or you are agree or disagree? What are your point? Okay, Laura, no question. Okay. So you have no more question about the review package? You feel strong? Because I can practice. Okay, is it? Can we practice number 11? Yeah, we can. Number 11. Let me try to find number 11. Number 11. Okay, number 11 is the inequality using absolute value. You want to practice exactly the same or another example? Okay, I solving the same example? Either. Okay. Okay, let me try to explain the key idea behind this. You have absolute value 7x plus 8 less than 20. Okay, how we interpret this inequality? Well, this inequality we interpret like one compound inequality. This is equivalent to say equivalent. This is the symbol in mathematics to say equivalent to say. You copy the expression inside, it's 7x plus 8. And this expression is in between 20 and -20. Guys, this statement is 100% equivalent to this statement. But the first way is confusing, and the second is clear, because it's similar to the inequality that we are solving in intermediate algebra. Let me see. You don't see the screen. Let me try. Guys, don't change the background. Let me see. Share. This background I don't like. Okay. Okay. Let me try. Randy, do you see that? No. Randy, do you hear me or not? No? Well, sometimes happen, I don't know why. So I recommend you go out and restart again to see the whiteboard. The rest of the students see the whiteboard or no? Andreina, do you see the whiteboard? Yes, amazing say I saw the whiteboard. Very well. And please don't change the background, please, because maybe this creates some problem. Okay? No. Okay. Do you see or no? Randy? Everyone follow me? Say, answer me, yes or no? Okay. The rest is piece okay. The rest is subtracting 8. Subtracting 8. This is 28, no? This is 0. And this is 12. Finally, 7x, sorry. Finally, if you want to solve for x divided by 7. This is negative 4. Okay, super. Now, never leave like that this answer, because in the test specification, okay, I want the answer in interval notation. So you write like that. Negative 4, comma, 12 over 7, parenthesis. This is the answer I want. Okay? Do you want to see one more example of this or no? Randy, are you there? No? Are you there? Are you there?
Yeah, here.
Do you see the whiteboard now?
No, I still don't see it.
No? Now?
Let me switch devices. I'm gonna switch devices.
Okay.
If I can see it.
Okay. Guys, any question? Do you want I do one more similar or no? No? Yes? No? Come on. Are you boring? Come on, answer me. Yes. What mean yes? One more similar or another problem? Yes, one more similar, no? Well, okay, let's do one more similar. Let me create one for you. Actual value 3x plus 4 plus 8 less than or equal 10. Suppose this. So what is the strategy? What is the procedure? What is the technique for solving this equation? Always isolate the absolute value. Like move 8 to the right-hand side, no? Okay, get 2. Very, very important. When the right-hand side in this inequality is a positive number, it's because we have two solutions. We have solution. This is the interval, one piece, because it's less than. Okay, this is equivalent to say, okay, 3x plus 4 is less than or equal to and greater than or equal minus 2. I read different because I read in opposite direction. No? It's actually this is less than or equal symbol, but this expression is greater than or equal minus 2. The rest is subtracting 4. It's a minus 6. 3x. And this is negative 2, no? Divided by 3. This is minus 2. This is x. And this is a negative 2/3. And the solution expressed in interval notation is bracket negative 2, comma, negative 2/3. Do you understand que bracket? Because we consider equal signs at the endpoint below. Good solution. This is the answer I want. Clear or confusing? Clear or confusing? Well, I want to complicate your life. Now I realize, you see, ask me about, I want to complicate a little bit. Okay, suppose this. Suppose this. Suppose actual value 1, 1, 1 minus 3x less than or equal 5. Okay?
Well,
Uh-huh. You say something?
no.
Okay.
But I see the board
You're
now.
putting off the microphone. Oh,
I see the board
why?
now.
I need to understand what's going on. It's
I
uh-huh.
think I was having some technical difficulties, so the the screen share came off, and
Oh,
I have no way of switching it back.
I understand. Okay. Entonces, this is equivalent. I copy the expression, que es 1 minus 3x. It's in between 5 and negative 5. Okay? Now you subtracting 1. Because my goal is solve for x, subtracting 1. This is a negative 6. This is cancel out. This is minus 3x. And this is 4, no? Positive 4. And that's it. This is the complicated part. Or not complicated, but tricky, confusing. I don't know the name. Divided by negative 3. So you need to be aware when you manipulate inequality and you divide or multiply by negative number, the direction of this inequality is reversed. Okay, actually, this is 2 positive. This is x. And this is negative 4/3. No? But the sign change like that. Do you understand this idea? I don't finish. One more detail, one more sophisticated detail. So this is a little bit confusing because normally the lower bound, que es this, is located in the left part, so negative 4/3 should be fantastic, and 2 here, and x here. And when you interchange this, again, one more time, you reverse the order. Okay, two reasons. This is classical in inequality manipulation. 2 reasons in which you have to reverse it, the inequality sign. When you multiply or divide by negative number, or when you interchange. Okay, now what is the final answer? The final answer is you copy the lower bound, you copy the upper, and in this case, bracket above, because included the endpoint. How do you know? Because it's equal. And this is my fantastic final answer. Any question? No? Let's do in So basically we focusing only in the less than. And what about greater than, guy? Greater than is different. Clear now, okay. Betancourt. Let's do in at least some problem of the greater than, no? Suppose the number 12, no? Nobody asked me, but I take advantage because it's similar topic, no? 2 minus 3x greater than or equal 10. Okay. So immediately you say greater than or is different to less than. Because greater than contain 2 intervals. The solution contains 2 intervals. Okay? Okay, look at that. This is my all real number line. Suppose hypothetically, this is 1 interval. This 1 interval is when there's less than. And two pieces like that, and like that, is when it's greater than. It's super easy to understand this idea because absolute value is the interpretation for the absolute value is distance. Entonces es when the distance is near, close, is one piece. When it's too far, it's outside the interval, but in both directions, because I don't care if it's positive or negative, because absolute value is the distance, and distance is the positive quantity, right? That is the reason that to understand or to translate this inequality and compound inequality, you copy the expression inside 2 times, and this is greater than or equal 10. So I copy exactly the same. The only thing I did in the first part was remove the bar. In the second part, put less than or equal. So I reverse the sign, minus 10. However, this complete statement is compound inequality because this. This is totally equivalent to this. It's the same thing. Expressed in a different way. In mathematics, there are different ways to express the same idea. And they are called equivalent. And this is the symbol that we use to equivalent. Equivalent. Okay, so we translate the problem que look like horrible and another que look like acceptable, understandable. And you solve it separately, this inequality, and finally we connect it by OR. And remember, OR is union, is put together without repetition. See, overlap something, not consider it. Okay, let's do it. We're focusing on this inequality. And this inequality is minus 3x greater than or equal 10 minus 2. Minus 3x greater than or equal 8. Divided by negative 3. Wow, again the same situation. Divided by negative number, reverse it. Is less than or equal minus a over 3. Entonces, for a moment, we have this partial result. Now, let's move on to the second part. Is minus 3x less than or equal minus 10 minus 2. I move 2 to the right hand side, opposite side, negative 2. Minus 3x less than or equal minus 12 divided by negative 3. Again, division by negative number, reverse the sign. 4. And this is one piece. And finally, we connected this and this using OR. How? Well, in my opinion, the super easy way is doing the graph. So normally, any compound inequality ending in one graphic interpretation. Infinity positive, infinity negative. This is 0 in the middle. 4 is 1, 2, 3, and 4. And 8 divided by 3 is 2 point something. No? 8 divided by 3, I put in my calculator just in case. 8 divided by 3, 2.6, 2/3. So negative 1, negative 2, negative 3, approximate here. This is the location for this point. And this is the location for this point. And the interval is greater than is bracket because include 4 in that direction. And this is less than is to the left. To the left. So what is my final answer? Well, my final answer is from negative infinity, comma something, negative a over 3, bracket of course, union, bracket 4, comma infinity. Recommendation and the test on paper enclosed in the box, the final answer always. To emphasize that this is my final answer I found. Okay, good. Very good to very bad.
Very good.
Do you want one more example or no?
Yeah, do one more.
Exactly. Of this kind or another?
Another kind.
Another kind. Which one? Suggest me. What do you want? Similar to the review packet, no? For example, you select, what do you select, mister?
No, give me 1 sec.
Huh? Come on, I waited for you. What problem you want? Get a repeat or create new one similar? No? So we start a new topic.
That's similar.
Which one?
For
Number 4?
no, not number 4. Number 11.
11. 11 I did right now.
Oh, you did 11.
Yeah.
Another one. For another one similar to 12.
Similar to 12. Okay, super.
Yes.
Let me complicate a little bit. Suppose 5 minus 2x plus 5 greater than or equal 10. Okay. Okay, this is greater than. So in my mind, immediately I recognize that the answer, the final answer we get contain 2 intervals, like that. So when I grade the test, this is classical in polar algebra. When I grade the test, I see that the student put only 1 interval. Immediately I put 0 in this question. I grade 0. Because you need to remember that greater than means 2 p's, 2 intervals. What is the strategy? When you solve, always you solve the absolute value part. I just bring down greater than or equal 10 minus 5. And 10 minus 5, 5. F5. Okay, and this is equivalent. Guy, this symbol, you don't need to write. If you like, and you understand very well, yes, but no. You skip to this, so I understand very well. Suppose you make this symbol. In the next line, you copy the equivalence expression, que es 5 minus 2x. 5 minus 2x greater than or equal 5, less than or equal negative 5. And you connecting these both inequalities by OR. Because actually, this is one mathematical object, not 2 separate inequalities. No, this is only one mathematical object. We need to solve in this compound inequality. It's equivalent to the original. Okay, let's do it. Minus 2x greater than or equal 5 minus 5. Wow, 5 minus 5 is 0. Minus 2x greater than or equal 0. Divided by negative 2. Entonces negative 2 divided by negative 2 is 1. But you have to reverse the inequality sign. And 0 divided by negative 2 is obvious 0. 0 have no sign. No? 0 is 0. And this is 1 piece. It's a negative number. And the second part is, let me try, minus 2x less than or equal minus 5 minus 5. Minus 2x less than or equal, this is negative 10. Divided by negative 2 both sides. X is greater than, switching the sign again, 5. Now connection. This and this together using conjunction or. Yes, union. This is equivalent union. Union. That is the reason we're using the U to connect in this. Okay, if you want, this is not mandatory. Do graphic to understand the geometry interpretation. This is 0. Okay, the first piece is that piece. Is from 0. It's negative, no? And negative. Include 0. Bracket here. And this is 5. 1, 2, 3, 4, and 5. 5 to the right. Okay. To infinity. Okay, so what is my final answer? What is my final answer? My final answer is
Negative infinity to 0 union 5 to positive infinity.
Absolutely perfect. Final answer. Super perfect. Any question? Come on. I suppose that when you see the test, you see, wow, too easy for me. Because we're discussing in detail everything. Could we do another number 9? Number 9. She said number 9. Yeah, of course, yes. Of course, yes. Number 9, a radical equation. Let me try to find another package. One similar. O sea, some students ask me, do for me, professor, one question similar number 9. Number 9 is typical radical equation. Okay. Let's do it. Let's do a radical equation. I found one different to the review package. Suppose this. Square root x plus 4 plus 8 equal x. And 21. Randy say, and 21. Okay, so Randy. And 21. Remind me when I finish that. Remember, radical equation is tricky because you manipulate the radical equation. Normally, when you manipulate, you get the quadratic equation, and we get two solutions. And you need to verification mandatory this solution into the original equation to verify if a solution or no. Because sometimes happen. This is classical in radical equation. Okay, we have something is called extraneous solution. Extraneous. OUS, extraneous solution. This is a technical name. You say que solution belong to the, this is the original equation. But you apply algebra and you transform it to the new equation. This new equation, you try to find easy to the original, easier, and you get solution. And this solution is a potential solution. And you need to verify. And when you verify, sometimes happen, not always. Suppose two solutions, and both are good. You have two solutions, one is good, another is bad. Extraneous solution. And we have two solutions, and both solutions are bad. So there are many possibilities. There are no rules, depending on the problem, depending on the example. Okay? Keep in mind this. It's mandatory checking. Yeah, I want to see in the test when you're solving. Some student, okay, solving perfectly, very well, but have no checking. Entonces no checking. Entonces we have no total point in this question. Okay? The checking is mandatory in radical equation. In another equation, no. In another equation, so in algebra, if you want to make sure that your answer is correct, you checking, but not mandatory. Only mandatory in this kind of equation. It's classical. Oh. Okay. Step number 1, isolate the radical. I don't touch the original. Why? Because I reserve this original to the last moment, get the checking part. Now square. Square fantastic transformation because square allow me eliminate the radical. And the next line, the radical disappear. No radical anymore. And here we have FOIL. No, actually it's x squared minus 16x plus 64. Guys, you are advanced students. Normally, when they explain this in intermediate algebra, we use FOIL. This is x squared. This is 8 minus 8. This is minus 8 repetition. It's obvious que repetition because it's the same binomial, ¿no? Entonces es minus 8 and minus 8 together is 16. Entonces actually it's twice. Twice what? Multiplication 8 and x together times extra 2. plus square the second, que es a squared, que es 64. You always plus it here. This is shortcut. The shortcut you apply, not always. You apply in a special product. It's when you multiply any binomial times itself. Okay? So the formula is a plus b squared is equal a squared, square the first, plus twice ab, the multiplication both, and extra 2, plus b squared. Entonces si es minus here, es minus in the first sign, but in the second it's always positive. Okay? But okay, it's up to you. So you memorize this, nice. You are doing fast. Si you don't, okay, you apply for it. Finally, I saw, I realized in that moment that we have a quadratic equation. Where's the clue that give me information that is quadratic equation? Well, these two. These two is a clue that give me information that we are in front a quadratic equation. So to solve any quadratic equation, we need to express in standards. In standard is, I try to move everything to the one side. Suppose that I make a decision, x and 4 move to the right. Just bring down this guy. Minus x, minus 4. And we combine like that. This is 70. 16. Negative 1 is negative both. Addition. 60 minus 4 is 64 minus 4 is 60. To feel more comfortable, at least for me, you put it in that way. You switch interchange. X squared minus 17x plus 60 equal to 0. Okay, and thus in that moment I focus in the solution of the quadratic equation. What do you recommend me? By factorization or quadratic formula? I have no idea. Help me, guys, help me. What do you recommend me? What do you suggest to me?
I think
Yeah, and do you see the combination? Quadratic. Another people say no, quadratic. Wow, quadratic. Let's do it in both ways. Because what is my recommendation? My recommendation is, what is the best way? No, there are no best. Depending on the problem. You spend 2 seconds, no 3, 2 seconds, to see if it's possible or not the factorization. So you don't see that, forget about this and go directly to the quadratic equation. But let's do them both. In this case, easy by factorization, but suppose I don't see the combination now. Okay. I respect. Exactly, it's 12 and 5. It's 12 and 5. Because 5 and 12, 5 times 12, look, 5 times 12 is 60. And 5 plus 12 is 17. And the sign is not important, but it's negative both. It's obvious it's negative both. Okay. She saw, or he saw, sorry, I don't know, I don't remember your name. Que es XX. Randy. It's 12 and 5. Doesn't matter the position. You put 5 here, 12 here, 5 is negative both. Because minus is positive. And minus addition is negative 17. Super. So the answer is 12. And the answer is 5. Okay. This is the student que saw that. The student que no, because don't like factorization, professor. I don't know why. Okay, you apply the quadratic formula, and I expect exactly the same answer. This is the beauty of the mathematics. It's exact science. A is 1, B is negative 17, C is 60. Wow. And substitution into the quadratic formula. Okay, minus 17, minus, the minus of the formula and the minus of the value is 17. Plus and minus, square root. Negative 17 squared. Minus 4 times 1, que es 8, times 60, que es C. Divided by 2 times 1, que es just 2. So I put in my calculator 17. I focus, see, and that part, look, let me make it zoom. My goal is compute that part because according to the order of operation, we are doing the operation inside the grouping symbol. Okay, the grouping symbol in this case is radical. 17 squared is 289. Minus something. Minus, it's 240, no? It's obvious que es 240. Minus 240, subtraction now, it's 49, no? It's 49. And the square root of 49 is 7. Okay, so far we have 17 plus or minus 7 divided by 2. Entonces yo split into pieces. 17 plus 7 divided by 2 and 17 minus 7 divided by 2. Entonces 17 plus 7 is 24, no? And 24 divided by 2 is 12. Wow, we get the same answer. Look at that. And 17 minus 7 is 10. And 10 divided by 2 is 5. Wow, we get the same answer. Do you see advantage and disadvantage of both methods? Okay, so you see, entonces I repeat my recommendation. My recommendation is you see the factorization combination, we are doing fast. So you don't see, because sometimes it's hard to see or impossible. So sometimes it's impossible doing that way. This is like a shortcut. Entonces we are doing by the quadratic formula, and all quadratic formula is safe because always we get the answer. Okay, what is the last part? This is the most important part for me. Verification. 12 and 5 into the region. Okay, let me copy the original equation. The original equation was square root x plus 4 plus 8 outside the radical. It should be equal x. I need to verification for x equal 12 and x equal 5. Let's do it quickly. Square root 12 plus 4 plus 8 should be 12. I claim this is a statement because I am not sure if it's true or false. Likewise, square root 5 plus 4 plus 8 should be 5. Again, the same problem. This is 16. Square root 16 is 4. And 4 plus 8 is 12. Super. We get the true statement. That means that 12 is good solution. And 5. 5 plus 4 is 9. Square root 9 is 3. 3 plus 8 is 11. Not 5. We get completely false statement. That means the solution doesn't work. It's a extraneous solution. And the only solution set that we have in this equation is 12. End story. Any question? Any?
No further questions.
Go ahead.
Just just to remind you about 21.
21. Let me try to find 21. 21. Okay, super. Well, in the test, you can find a combination two functions. This function is given in equations. Okay. Suppose you have two functions, f and g. And we have combination both. Combination using addition. Combination using subtraction. That way or in opposite way. Multiplication or division. Or composition. Pero bueno, composition is another problem. The symbolic way to indicate this idea is f plus g. This is one symbolic. Totally symbolic. This is subtraction. This is multiplication. Period. And this is division. Division is F divided by G of X. Okay, in this case, okay. The first question is find the new expression. Find the new expression is okay. You subtract and addition. But the complicated part is stays domain. So the question contains two parts. Find new expression. I suppose that this part is no problem with you, for nobody. And the most complicated part is stays domain. Well, domain in this case is domain of F intersection domain of G. It's the intersection or and. So I suppose you have restrictions. It's the restriction of the F and this is equivalent to say and the restriction of the G together. Suppose we have no restriction, okay, no problem. It's all real number, right? In this case, no. In this case, it's more complicated. Domain of F intersection domain of G intersection, o sea, and another and the value in which G is not zero. Okay? This is more complicated. So in the problem that you asked me, que es 22, is exactly the same idea, is division. Because division is the most interesting example of the combination of information. Okay, is, look, suppose f of x equal 7 x squared minus 6x. This is the equation or the expression for the f of x, and the g of x is x squared minus 2x plus 24. And they want find the expression f division g question mark and state is domain of the new function que es the combination of. Okay, you have two questions. Let's do it one by one. Okay, the expression is pretty easy. You put it f in the top and g in the bottom. In the story. This is my first answer. My second answer, it's a little bit more complicated because domain is, what is the domain of this guy? Domain of this function is all real number because it's polynomial function. Remember the restrictions. That is a classical question in color algebra. Determine the domain of the function. Determine the domain of the function. So domain, the agreement, the supposition is domain is all real number except restrictions. A restriction we have in three situations, and they are combinations. Condition number one is when you have p divided by q, it's a fraction, the denominator not zero. This is the one first kind of restrictions. The second is when you have a square root. The expression inside must be non-negative. And p divided by radical e is when the radical is in the denominator, e no, is positive, only positive, no negative, no zero. In this specific example, this apply this restriction. The thing I need to investigate is if my expression in the denominator is this, I focus in this. I don't care temporarily that part. No, this is totally irrelevant now. I focus on this. I need to prove if this inequality has solution or no. Okay, entonces, wow, entonces I realize que this inequality look like similar to the quadratic equation, no? Similar to the quadratic equation. I know that it's not the same. It's not equivalent. Hello. This is the complementary. Complementary means totally negation. Okay? Totally negation. It's completely opposite. So the good guy here is the bad guy here. And the good guy here is the bad guy here. It's complementary. Negation. But okay, I feel more comfortable with the solution for the quadratic equation, no equal sign. When I finish, I copy the value x equal 2, suppose. Because actually, I know it's not 2 because it's the original problem. So you solving this quadratic equation. Let's do it. Let's do it. Let's do it. In this case, by factorization is crazy. No, we using quadratic formula. A, B, and C. A1, B is -2, C is 24. Entonces I apply the quadratic formula one more time. Okay. So it's 2 positive, double minus again, minus, become positive. Plus and minus, square root, -2 squared, minus 4 times A, que es 1, times C, que es 24. Divided by 2 times 1. Okay, and we focus it in the operation inside the radical. Let me make a zoom. Here, over there. -2 squared 4. Minus 24 times 4. Well, I suppose 24 times 4 is 96. Entonces, when you're subtracting, it's 92, negative 92. And when you apply square root negative 92, I stop here. Stop. Why stop? Because it's imaginary. It's I square root 92. So immediately you say imaginary, that means that the restriction that you try to find living in another dimension that is no all real number, living in another planet, maybe Jupiter, okay, no Earth. Therefore, I don't care this. So this is a classic analytic. And we are apply. I recommend that you memorize this idea because we're using not exactly in these ideas and another. The thing you try to find, you set out the equation, nice. You solve the equation, nice. But in the middle, you find that the solution is imaginary or complex. What is the interpretation of this? The interpretation is that the restriction I try to find do not exist. Okay, professor, so what is the answer? Well, the answer is, I come back at the beginning, look. The beginning said that the agreement was, the agreement was que they don't make all real number except the restriction. But the restriction do not exist. Therefore, what is the domain for this combination of the function, all real number? In the story. Do you understand or is confusing? Suppose another example in which exist. Entonces, all real number except the value of the solution of this. But in this example, do not exist. For me, it's important because this is frequently happening in the algebra. Can you try to find something that you believe is good, and suddenly happen? Wow, it's imaginary. It's imaginary. That mean it do not exist. Any question? Any question, guy? You pay attention or no? Okay, no. No question. Okay. Super. Randy. No question. Okay, one more. No question about the review. Oh no, I forgot to explain composition, no? Maybe, right? I explained addition, subtraction, multiplication, and division. Composition is a little bit different. Okay, composition. Let me explain composition. Let me erase the bar. What is the idea behind composition? Suppose we have two functions. I don't want to complicate. F of x equal x squared plus 2. Semicolon, g of x is equal x cubed. That's it. I want to find the composition. Suppose I want to find composition F composition G. Okay, in general, it's completely different to G composition F. It's no commutative. We cannot interchange. In some particular example we studied in another chapter, yes, it's possible. Switching and the answer stays the same, but in general, no. Entonces, you need to understand the composition like one chain rule. Okay, basically, what is a chain? Because we have to function. And the interpretation for the function is a black box. And when you have input is domain, x value, domain, and the output is range. But in this order, we have two boxes. And the order is x get inside first and g. So this is my first function. And this is my second function. Okay? Suppose, numerically, to understand. Suppose que f composition g evalúe en 3. En 2. Entonces yo evalué g en 2 first. Bueno, sequentially. G en 2 is plugging into here. 2 squared plus 2. 2 squared is 4 plus 2 is 6. Okay. And this is x equal to, and this give me the output 6, que es y equals 6, que by the way is x equals 6 for the second function, because it's the same, right? And now you evaluate 6 into the f. F evaluating 6. F evaluating 6 is F no. Carajo. I make a mistake. Look. This is G. Okay. It's G. G is cubic. Okay, the mistake in that part. The mistake is in that part. Okay. No super big mistake. So you evaluate G. G en 2. G en 2 evaluate here, no en F. Carajo. Entonces 2 cubic. 2 cubic is 8. This answer is 8. Okay, this answer is 8. And finally, you plug it in F. F is that function. F evaluating 8. F evaluating 8 is a squared, is 64 plus 2. 64 plus 2 is 66. And the final answer here is 66. And the y value is 66. Do you understand the idea behind the composition? It's like a chain rule. In this case, we have two functions, 1, 2, but we have several functions. You have F, composition G, composition H. So this is the order. This is the first, this is the second, and this is the third. In calculus, you can see this idea. Several functions together, okay? And the composition is one function go inside another function. Okay, but what is the goal in algebra? Go ahead. Okay, super. Now, what's the goal in algebra? In algebra is, suppose I want to find the new expression for the composition. This is the new expression. Suppose the question say, no that part, no evaluating the point. No. Find the new expression. Okay. New expression. Okay, new expression means que G, que is this expression, go inside this. Entonces F composition G of X is equivalent to say X cubic squared plus 2. And leave it like that? No. You apply the rule of the exponent is x to the 6 plus 2. Let me check in just in case si I make a mistake or no. F composition G evaluating 2 is 2 to the 6 power plus 2, and 2 to the 6 power is 64, and 64 plus 2 is 66. Exactly the same. We get numerical step by step. We can get in one step because I condense in these two functions in only one, case composite. An extra question, state is domain. Okay, the formula to state is domain in the composition is a little bit different. It's a little bit different and complicated. The domain is domain of the first function que you consider. In this case, according to this order, is G. So any value que is undefined in the first function is totally out the domain of the composition. Que the composition, remember, is both together, no? Now, Daniel, wow. Some people send me email. Intersection, domain of the new expression. This is the idea. No F, sino new expression, que es the combination both. So basically, I need to find the domain of G, que es this, and the domain of this. But in both cases, this is polynomial function, poly, and this is also poly, no? Degree 3, degree 6. And you know the polynomial is all real number. So we have no restriction. This is the domain of this composition is all real number. Okay, all real number, intersection all real number is all real number. Do you understand? It's a little bit confusing. We need to practice more or no? No? More? Practice more? Come on, guys. Are you sleeping? A little confusing. What part is confusing? You could help me to a little bit confusing. What part is confusing? Activate the microphone if you want to ask me directly. Come on, participation.
It's just a lot of information.
I know.
Probably get it. Yeah.
Okay.
After a few
I know
examples.
it's a lot of information, and this is, Mister, this is just the beginning. You have no imagination, the information that you can receive this semester.
Okay.
Okay? But the chairperson of the mathematics say that you are selecting students. Okay? Another student I have, in another class, it's a mess. Okay? You are selecting a student. I am your teacher. I am your friend, never enemy. You can ask me any question. Some people, because we have in pandemic time, some student, not in this class, but in another class, email me with the condition, no? The family or herself or himself. Okay, it's important. Stay the communication in between us. Any problem, I understand, no? Entonces I can extending a little bit, you, Alex, I don't know. O sea, es important communication. Without communication, when they check in the Alex, you don't do anything, 0 for you. They posting in Blackboard, 0. Okay, and you communicate with me. I know your problem. I don't know in detail your problem. You explain me quickly, briefly, no in detail. No, I have a situation, certain problem. Okay, this is good. I understand because I am human. No, I am no the square root symbol. No, I am human. Any other question? Any other question? Entonces si you have no question, no more question, you feel strong, of course you need to spend time this weekend doing the Alex, no? I forgot to say something. Well, okay. See, you feel good. I recommend stop here, no? Stop here. Entonces now, stop or no? Or you will have another question. Who changed this background, guys? I don't like this background. Okay. So you have no question. I want to send right now the test. Okay, entonces you waiting some second, no? Confirm me. I got it, professor, or no? So you don't receive the test, you email me back as soon as possible, and I reply with the copy, special copy for you. Okay? I want to send that now. Boom! I sent. Let me know. I'm waiting. Okay, so you can leave. So you receive and you got it, you can leave. So you have busy weekend doing the test on paper and the Alex test. Okay, any question about the homework or pre-test, you can send me the screenshot with the specific problem. I try to help. Pleasure, always, anytime. You too.